Hello, good afternoon. I would like to present you results of two challenges from Agrihub INSPIRE Hackathon 2022. It's about challenges number 5 and number 6. Both of them are dealing with IoT and Earth observation data, and it's processing, visualization, and integration in some end-user application to allow these data sets to be more and easier accessible for end users, especially farmers. We have decided to join effort in both of these challenges because we are dealing with similar data sets. We are trying to cooperate on one end user application, and we are trying to integrate both local sensor data together with remote sensing data and its products and derivatives. So that was the reason we have joined effort in these challenges, and we would like to present together results of our challenges. We have been working on, let's say, one pilot locality in South Moravia in Czech Republic, and we have tried to combine data sets from previous season where we have high density sensor network with 100 sensors for soil monitoring in 5 square kilometers area, and we were combining these data sets together with remote sensing data and different indices and classified images to provide results not only from local monitoring but from, let's say, global perspective as well. Similar data set was used in cooperation with challenge number 4. So if you will see similar data sets, that's the same data set. Okay, so let's move to first result, which is, let's say, update of FIE 20 application. This application is combining web map application together with additional functionalities, especially in, let's say, integrating data sets in one map window. So at this moment, you can see deployed sensors in their locations, how it was distributed in 2021 season, and together with, let's say, topographic map as base map, and these blue contours are LPIS field blocks. So how you can see distribution of sensors on fields. Very simple interface, so user can change different data sets. At this moment, if we start, let's say, with this local monitoring, we can look on data, how they are measured. So we will switch to sensor panel, and you can see a lot of sensors deployed in the locality. The new functionality is that if you move on one sensor, it's listed in empty chart, and then you can select which sensor you would like to see. So for example, this one, and what phenomenon we would like to look at. So for example, soil thermometer, you can see two sensors in two soil horizons. So for example, 5 centimeter underground and 15 centimeters underground. And you can see the chart of 2 values in last one week, together with some minimum, maximum average values. Or we can look on, let's say, months back. So how how these values are changing. Or we can look on different phenomenon, for example, volumetric water content in both horizons as well. And you can see how it is changing or how it is measuring in last months or a shorter period, one week. So very easy how to present such data. What is new functionality developed during this hackathon as well is, let's say, interpolation of values in this area. So if we are not focusing only on one sensor in one particular place, we can look on, let's say, same phenomenon on the full area. So how to interpolate these values, and it means that at this moment it's showing the last value of each sensor in numerical way on each place. But we can interpolate these values in raster, and then we can visualize results of these results of this interpolation. So the last values interpolated in one raster. As you can see, some sensors are not measuring at this moment, so it means that these zeros, but rest of them are providing some values, so you can see interpolated raster. What we would like to do as, let's say, further step will be interpolation based on, let's say, defined timestamp. So not only the last value, but to provide interpolation on, let's say, user demand. So user will select available dates and times, and then in a raster will be interpolated based on, let's say, selected timestamp. That's for the next development. Okay, then we can not only see, let's say, measured data, but we can look on combination with some indexes or remote sensing data at all. So we have a lot of additional data sets. For example, average pixel value in EVI index in year 2020, and you can see it is calculated for the full area of the pilot farm company, and to see how it is developing during this period. Or we can look not only for some average pixel for the full year, but we can look for some average in particular date. So at this moment, 22nd April 2020. So how it is developing. Similar way, we can look on, let's say, evolution of classification, how it can be recognized, which crop is on particular fields, and then results from or information from LPIS data, what exactly was on each field in this defined zone. What we are at this moment developing for, let's say, next steps is some averaging or calculation of averages for defined timestamps. So from defined time range, calculate some average how this index was changing in particular period. So instead of switching on, switching off different layers, user should be able to just select particular period, and then this raster will be calculated based on original data sources. So that should be the improvement for next steps. So that's all from our side, and thank you for your attention.